Hi everyone, I'm Anish and welcome to PrepFusion. So today we will be starting the lecture 4 of block diagram and SFG, right? So previously we did few questions, and before that we learned what is a signal flow graph. So in this lecture also I will again do few more questions to get a good grip on the signal flow graph topic basically, and we'll learn the limitations of Mason's gain formula. Okay, so what are the limitations when we cannot use the Mason's gain formula, and what modifications we need to make to be able to use the Mason's gain formula? Okay, so this is the first question. We have been given that the block diagram of a system is shown in the figure. The block diagram is something like this, and we have to find the transfer function. Okay, so it is not the question hasn't told us, but we have to find the ratio of y upon 2. Okay, so let me write here only. Uh, find y upon u. Okay, find y upon u. So I will solve this using two methods. First one is normal equation method, and the second one is signal flow graph. Now why am I solving this using two methods? To show to you like which one is more easier and which one is more suited towards you, right? Which one is more suitable for you. So it is important to know that also, and it is important to know multiple methods for solving a single question. Obviously in gate you will solve using a single method only, but you should know multiple methods. So if you get stuck in one method, then you can do it in the other method, right? So that is the reason. Okay, so yeah, let me first copy this and write the equations. This is the gate question 1992. Okay, copy this. So what will be basically the equation? So what I can do is like what I'm seeing u over here, but I don't know this point or this point. So let me assume one of these points, and from there I can start. So let me assume this as x, right? So if I assume this point as x, okay, this point as x, then this x is coming over here, getting multiplied with h and becoming x times h. And now what is happening? This u is coming over here, and this xh is getting added, right? So this is u plus xh. Okay, this is u plus xh. Now this u plus xh is getting multiplied with this gain block, and here it is becoming u plus xh times g, and here also it is u plus xh times g, and again it is getting multiplied with h. So here it is becoming u plus xh times gh. Now it is getting added with u again. Okay, with u it is getting added again. So this will become u I take common. Okay, u, if I take common, 1 plus gh plus xgh square. Okay, so this is the form. Then again I multiply with x and I get back x again. So I can find the relation between x and u and replace it over this equation. Okay, the value of x, and I will find the relation between y and u, right? So yeah, let me do that basically. So here this point is u into 1 plus gh plus x gh square into g, right? So now what will this let me equate this with x, right? Let me equate this with x. So let me write the equation basically. X equals to u into 1 plus gh into g plus xg square h square. Okay, so what I can do is simply take common here 1 minus gh whole square, that is equals to u into 1 plus gh times g. If you hear a few background noise, it's because this time is around Diwali, so everyone is bursting crackers and all those things, so that's why there may be a bit of sound. Okay, So now let me replace like this 1 minus gh square, right? What I can write is 1 plus gh into 1 minus gh. So 1 plus gh will get cancelled with this one, right? Will get cancelled with this one. So what I will be left with is u into g by 1 minus gh. So x equals to u into g divided by 1 minus gh. U into g divided by 1 minus gh. So now what will this become? So here what I have, x plus u into xh into z equals to y. So what is y equals to? Let me write it in different. What is y equals to? Y equals to x plus u plus xg, u plus xh xh into g, xh into g. So this becomes y. I take x common here, so this is 1 plus gh again, okay, plus ug. Okay, now what is this x equals to? X equals to ug into 1 minus gh. So y equals to ug. I take common, right? 1 plus gh divided by 1 minus gh plus 1. Okay, so next I can simply add these two. Okay, so this becomes y equals to u g 1 plus gh minus, okay, plus 1 minus gh divided by 1 minus gh. This is ug 2 divided by 1 minus gh y by equals to 2g by 1 by gh, 1 minus gh. Okay, so this is the solution using the equations. It doesn't seem too much difficult, or it isn't too much easy. Okay, so let's solve using the SFG. From there we'll understand like which method is more simpler to solve. Okay, use basically. So let me copy the circuit diagram again, like the block diagram again. Okay, now let me name the nodes this time. So what I will do, so for you it's difficult, okay, because you have to do it in the screen, right? So you don't name this node directly, you just directly draw the SFG, right? For me it's easier, okay, that's why I name the nodes. You start with directly drawing the SFG in your exam, okay, but here you can do practice with me slowly. With more efficient practice you will get to like better at drawing the SFG directly. Okay, all this comes with practice. Okay, so let me start over here, this point, right? This is m, let's say m, and this point, right? This is also like, okay, this point is nothing, this point is an adder, right? Let me name this point as m. Okay, now let me name this point as n. Okay, now what is the other point? This is the another adder, that is o. Okay, then I will go like this only, I will go like this. So let me name this point as p. Okay, then let me name this point as q. So all of these points are named, one of these point is not named here, like these three are coming together, right? So what I can name here is r. I can name this one as r. Okay, so this is m n o p q r. So now what I can do is draw the SFG for this one. So let me take different pen. So here we have u is coming to r. Okay, then this r is going to m, right? Another note. Then this m is going to n. Okay, then this n is going to o. Okay, then this o is going to y, and this o is going to p. Okay, now this is going to q, now this is going to r. So r u m n o p q, and in between we have connections, right? So between q and n we have a connection, so we can draw it like this, and between m and p we also have a connection, right? So we can draw like this. Okay, So this is going like this, and we have a plus sign over here, plus sign. So we don't need to write minus h, we only write h. So this is also h, right? And what is this? This is also g, and this is also g. Okay, so this is one only, and this is also one only, and this is also one. And this is also one. Okay, so all these are the SFG. Okay, points of the SFG. So this is y by r. So yeah, now this is the SFG. So what is the like number of forward paths here? So what I can see is simply, like, if you see, right, just pause this video right now and tell me what is the number of forward paths right now. So this is, I'm going from here to here. This is one forward path. I'm going from here to here. This is 2. Are there any other forward paths? Like, it doesn't seem so too obvious to me. Okay, if there are any forward paths. So what did you guess? You guessed 2. So if you guess 2, you are wrong, because like if I go from here, right, and then like go to here, this is one forward path. But if I go from here and here, so I get another forward path, right? I get another forward path. Also, what other forward path can I get? Okay, I made a mistake over here. Okay, like this one was from here, right? I made a mistake in directions. Okay, that is what I was thinking. I'm making some mistake, right? So if I go from here to here, okay, not I can go from here, but I can go from here to here, right? So this is one forward path. Now I can also go from here to here. Okay, so these are 2 different forward paths, right? From here to here, from here to here. Okay, 2 different forward paths. So like, how many total number of forward paths we have? We have 4 number of forward paths. So this one I will solve slowly, because this is a big SFG, right? So you can't directly solve it, just you're writing the formula and solve it there only, right? You have to solve this slowly bit, because this is a big SFG. So yeah, just be careful for a big SFG. Total number of forward paths equals to, simply equals to 4. Total number of forward paths simply equals to 4. So what are the different forward paths? One is, let's say one is this one only. Okay, this one only. So what I can do is like write the gains, right? So this is P1, and what is the path of P1? P1 is URMNOY. URMNOY. Okay, MNOY. And what is this path? So this path is URQPOY. Okay, let me just write the gain of this path first. So this is 1. Okay, let me write this in better manner. This is 1, right? So this is like 1 times G times 1 times 1. So this is G only, right? And let's say I am writing the gain of the second path. So what is the root of the second part? It is URQPY. URQPY. So what is the gain of that path? This 1 times G times 1, which is G. Right? Which is G. So what is now what is the P3? What is the P3? So P3 is this one, right? Going from here to here, then coming back here to here, right? So this is URQPMNOY. U R Q P M N O Y. This is, what is the gain of this? This is 1 times G times H times G times 1. So what is this? Like basically G H G. Okay, so it is G square H basically. G square H. And what about P4? What about P4? So P4 is basically this one, right? So it is going from U R M N Q P. U R M N Q P, and from Q P it is going to O Y. Am I doing this correctly? Okay. U R M. Okay, sorry. Yeah, M N Q P O Y. Yeah. Okay. Yeah. Q P O Y, right? Q R M N Q P O Y. Yeah. Okay. So what is the gain? G H G again. So G square H again. So it is G square H again. So this is the P4, right? This is the P4. So yeah. Now let us write the determinant of that this SFG, right? So let me copy this. Let me make this smaller. So how many loops can we see? It may seem that we have some loop over here. Tell me like how many loops can we see? Okay, so pause the video and tell me. So like what I can see, can I go it like this? No, there is that flow direction is opposite. Can I go like this? Yes, I can, but here I can, again the flow direction is opposite. But what I can see is if I go from here and from here to here, yeah, I reach the same point where I started, and we aren't going against any flow, right? We are going with the flow. Is this? No, this is also not a loop. Okay, so only what I can say is this is the only loop that I can observe here. So even though the diagram is very big, we have only one loop. So number of loops is only 1. So what will be our delta? Delta will be 1 minus the loop gain, right? So what is the loop gain? It is GH. So it is GH whole square. Okay, this is the loop gain basically. So now let us see how many number of individual isolated loops are there. So like it is pretty obvious that if I remove this forward path, yeah, only one loop we have and the loop is here, so the connection is lost. So yeah, not possible. Again, if I remove this, not possible. Again, if I go from here, yeah, again not possible, this will be removed. Again, if I go from here, the loop itself we are pressing, right? So number of individual loops is 0. Individual isolated loops. Loops is 0, right? So like what will be the delta? Delta 1 will be 1 minus 0, which is 1. So we'll copy for all of them because it's same for all of them, right? There aren't any isolated loops, right? There aren't any isolated loops. So let me just delete this. 2, 3, 4. Okay, so let us write the whole formula right now. That is y upon u, right? So y upon u I am writing. So what is this? So what was the forward path gain? It is g plus g, 2g plus 2g square h. So 2g plus g square h basically. Okay. Now what is the delta? Delta is 1 minus g h whole square. Also I can take the g common. Okay. We have 1 plus gh divided by 1 plus gh into 1 minus gh. So one minus gh. Okay, so yeah, this is basically the solution. So as you can see, like whichever you find suitable, you can do this a bit quicker also, but there may be chances of mistake. You may miss that forward path, right? So you have to be a bit careful with this. So this was the solution for this question using two methods. So let me write here that this one was the method 2 SFG, and this one was the method 1 using equivalence. Method 1 using equivalence. Okay, so yeah, let's do another question again. So this question is interesting. Why? Let's first read the question. So this question is asking us to find is the block diagram of a system is shown in the figure. So the block diagram is this, but the interesting fact is we have two inputs, right? Also we have to find the transfer function with respect to another input, that is E of s. So you may ask, sir, like you told us that we can't just give another input and find the transfer function, right? So how will we find here? So due to this, right, due to this one, okay, due to this one, because the other input is 0 this time, and this SFG follows linearity, so I can simply use the principle of superposition, find the transfer function for one of the input due to like when the other input is off, okay. And for this one, right, E of s, I will show you how to solve this one. We can't directly solve, okay, we can't directly solve using SFG because this is, we are not giving an input here. This is not an input, okay, this is not an input, okay. So that for the first time that I told you, right, we can't solve using SFG for which is not an input. So how will we solve? I will show to you, okay. But for this N and R, right, yes, they too are input, but we will not solve them simultaneously. What we'll do is we'll solve one of them, then make the other one 0, okay, then we will solve the other one, then we will make this input 0 and find the transfer function, okay. That's why, like, the what is the question asking? It is asking us to find the ratio of y upon r. So this is one input when the other input is 0, right? Then it is asking us to find y upon e when the other input is 0. One input has to be 0, okay, else we won't be able to find the transfer function. Now how will I find y upon e? I will show to you, okay. Then we have to find y upon n. Simply make r 0, okay. Then we can simply find using the SFG formula. This and this we can simply find using the SFG formula, okay. I hope you are understanding. At the end, we have to find the output y of s when r of s and n of s are applied simultaneously. How will I write the equation? I will show you, okay. This 18, all those things we will better see. So yeah, like I haven't like taught you yet, like what are, like this is a multiple input single output system. So if you have a like meso system, so this is known as meso system. So how many types of systems we have? If I have already taught you, that is well and good. If I haven't, just see from here. We have like 4 types, mainly meso, memo, and ciso and CMO, right? That is like multiple input, single output, multiple input, multiple output, single input, multiple output, single input, single output. So name like explains itself. If we have multiple input parameters, right, and we have only one single output parameter. For example, this time taking example, don't take it forward. Okay, let's say we have AC, right? AC takes multiple input parameters, right? Let's say it takes as like temperature, it takes the humidity, also it also takes many things in the system, right? Water and all those things, but it gives output as the air, how much cold the air it is giving, okay. So it may happen you may give it like memo also, but just for the example, just try to understand. AC takes multiple things in input but gives a single thing in output, just the air, right? How much cold air it gives, okay, the amount of coldness on the air, okay. So yeah, that is one example of meso. Now memo, like you can say, yeah, the thing that controls the temperature of room, it takes a heating, it has heating element as input, how much temperature it takes, how much humidity it has, and output it gives two things, okay. It gives like humidifier, and it changes the temperature also. So yeah, that way you can think like memo system. So another one is memo, and the third one is simply CMO. So CMO is very interesting. So it has single input and multiple output. So what you can think of it is like a decoder, you can say decoder, or a multiplexer also. Like it takes a single input and gives multiple output, or a transmitter, right? Or a transmitter, okay, or a transmitter, you can say that, like transmitter transmit signal to multi-channel. It takes input from one channel and gives signals to multi-channel, okay. Like that also you can think of examples. So this was just for the example. Now let's solve the question, right? So let me copy the block diagram. Copy the block diagram. Now what is the first question? First question is simple normal question, that is find y upon r when n is 0. So what I can do is, firstly I will solve this using equations, and then I will solve this using SFG, okay. So let's see like which one is better, okay. I try to always solve with two methods, so that you can understand using two methods also. But first pause the video and solve this by yourself, okay. Then you see my solution. So what I will do is solve with equations. So I have to make n 0, right? So I can simply remove n, right? Remove n, okay. So if I remove n, like what I can see is I can reduce this block, right? This is like a negative feedback system. So yeah, if you like, that is how we use it in combination, right? Equations and block diagram reduction techniques. So that's how I used to use it in exam, not for solving the whole question together. I reduce the block to a simpler block by using a block diagram reduction technique. Then I use my equation thing, right? So that will make me like, that will help me in solving the question in much faster manner. So it is important to think like that also. So what will this become? So this will become 10 by s times s plus 1 divided by 1 plus 5 by s plus 1, okay. So let us multiply s by s plus 1. So we get s into s plus 1 plus 5 s only, okay. So this is what we get as the transfer function, right? So yeah, let me delete this and write over here, right? So this becomes, right, I have to delete this also. This becomes 10 by s into s plus 1 by 5s. 10 by plus 5s, okay, plus 5s. So yeah, this is what this becomes. Now I will use the equations. So what is this? This is y only. This is y only, right? So this is y only, okay. Y only. So what is E equals to? So here I have R only. So E, right? E is equals to R of s minus y of s. So this is the basically we known as also the steady state error. Yes, this will be solved in like the time response chapter very intensively. So this is one important part of control system. But let's not think about that right now. Let's just solve the question. So here E of s is getting multiplied with s plus 2 and getting added with 2r. So this is what? This is 2r, okay. 2r. So here we have s plus 2 into E of s plus 2r. Now I will multiply with this block and I will get my signal y back, okay. So I will not write the s bracket term right now, okay, directly solve it. So 2r plus this one, right, this signal, okay, this is already added, sorry. 2r plus s plus 2 into E of s, which is r minus y basically. R minus y basically. So r minus y into this one, right? 10 by s into s plus 1 plus 5s, which is equals to y itself, right? Which is equals to y itself. Now we will solve this, right? So what I can do is simply multiply, like go this to over this side, okay? And this is 2 plus s plus 2, and this y goes over there, okay? I hope you are understanding my calculations. If you can't, you do it by yourself, okay? I'm just copying few steps. So in gate also, when you are very accustomed with solving questions, you have to skip few steps, right? So this becomes s plus 2, okay? So now let me solve this. So r into s plus 4 basically, okay? R into s plus 4, and what does this become? This becomes, right, y into s into s plus 1 plus 5s plus 10s plus 20 divided by 10, okay? So what is y upon r? What is y upon r? So y upon r is basically 10 into s plus 4 divided by, I should write this in quadratic formula, s square plus s plus 5s plus 10s, so it becomes 16s, okay, plus 20, okay? So this becomes 10 into s plus 4 divided by s square plus 16s plus 20, okay? So yeah, this is what is the solution when this n equals to 0, right? So now let me do one thing. Let me draw the SFG for this particular block diagram, okay? For this reduced block diagram. So what will be my E of s? Again, let me solve the E of s. So I will find this using SFG, then I will find the E of s. E of s is simply equals to r minus y. So I will put the value of y like this in terms of r, and I will find E of s in terms of, sorry, we have to find y by e, right? So I will put the value of r in terms of y, and there from there I will find the E of s. I will not use SFG for finding y upon e, right? So part B, this one, I will not use SFG. So first let me find the solution using the block diagram, okay? Using the SFG, right? So this is the E of s, okay? Now let me write the name of the nodes, right? So let me name this as M, okay? M N O P, okay? And this one is Q only. What I can do is, okay, sorry, this noise, okay, what did I copy? I copied the wrong one. Noise wasn't there, right? Where was this one? Yeah, I should have copied this one. I copied the wrong one. So what should I name this as? This is already R. This is M. This is N. And this is simply this. What I can do is this I can name as M, right? This I can name as M, okay? Because this is, here we are taking from other point, right? So this point and this point isn't same, okay? But here this is already named R, okay? No worries. But still I try to separate the input with respect to other nodes, right? I just try to keep the input as other node, as a separate node. So this is M, N, O, and this is P, okay? So now let me draw the SFG for this one. So how to draw the SFG? So it is simply equals to Mn O, and this is P, and this is OFS. So this is basically Okay, this is M and O. Okay, we have another node also. This is R. Okay, this is M, N, O, and P. So from M to O we have a gain of 2, right? So M to O we have a gain of 2. Okay, now from M to N we have a gain of 1, right? So this is 2 and this is positive. Okay, so this is 1. And from P to N we have a gain of -1 because this is negative. So P to N. Gain of -1. Okay, so what we can write here is this as 10 by s plus 1 into 5 plus 5, right? So this is that gain and this is 1 only. Okay, and from N to O we have a gain of s plus 2, right? So yeah, this is 1 also, this is 1, right? So yeah, so what will be the overall transformation? So let us find the number of forward paths. So we'll try to write this here directly. So how many number of forward paths we have? Like you calculate it for yourself. This is 1. Okay. This is 1 forward path, the simple one. Is there any other? Yes. This one is the other one, right? So first let me write the gain of this one. So it is 1 times 1 times s plus 2 times this times 1. So what will be the value? I will write the transformation directly this time. So it is 1 times 1 into s plus 2 into 10 divided by s into s plus 1 plus 5s, right? Plus 5s. Okay, so yeah, this is the forward path. Now what I will do is add the other. Now what I will say is, are there any, what is the determinant of this? So how many number of loops are there? So what I can say is this one is one loop. Okay, is there any other loop? If I go from here, no, I can go here. If I go from here to here, again, like this point is getting repeated, right? This is not the starting point. So this is also not a loop. We have only one loop present. What is that loop? This one. This one is the only loop present. So what is this? This is the same multiplication but in minus sign as the numerator multiplication. Okay, this is minus 10 into s plus 2 divided by s into s plus 1 plus 5s. Okay, s plus 1 plus 5s. So now what will be this isolated loop gain, right? Before adding, right, I have to multiply with isolated loop gain also, associated loop gain factor. So if I remove this, right, if I remove this, we have only one loop left, so this will be ineffective because this is floating, right? So yeah, this is 1 0 only, and the other one, other forward path, right? So what is that? That is simply 2 times this one, right? So this is 20 divided by s into s plus 1 plus 5s times, again, what is the number of isolated loop this time? Again I am going like this. So if I remove this part, yeah, this loop is finished, right? So we have only 0 gain here. We only 0 gain here. So what is this? So the denominator of all of this are same. Okay, I can simply cross multiply. So this is 10 plus 2. Sorry for the noise, actually they are like cracking too much firecrackers right now, too many patake. So what does this become? S into s plus 1 plus 5s plus 10 into s plus 2. So this is 10s plus 20, which is let me take 10 common here, right? So s plus 4 we have at the numerator. This is y upon r and the denominator what we have? Denominator what we have? We have this one, right? So what is this? S square plus s plus 6s. Again, this is 16s and this is 20. So this becomes simply s square plus 16s plus 20. Okay, plus 20. So this is again the same solution that I get using the simple equation technique, right? Where n is equals to 0. Right. Now what I will do, I will find the value of E of s, right? E of s, which is equals to R of s minus Y of s. So what I will do, I have to find, what do you have to find? Y of s upon E of s when n equals to 0. So I will find using this, not using SFG or something. Okay. So what I will do is simply write this R in terms of y. So y into s square plus 16s plus 20, 10 into s plus 4. Okay, and this is minus 1. Okay, this is minus 1. This is minus 1. Okay, so now I can write here, like simplifying this equation, right? So E of s equals to y of s into simply s square plus 6s, s square plus 6s. Now this is 40 is getting subtracted, so this becomes 20, and in denominator we have 10 into s plus 4. So what I can do is cross multiply. So y of s upon E of s equals to 10 upon s plus 4 into 6 s square plus minus 20, right? So yeah, this is how you can solve it. This is one method, but if you want to say no, I want to solve using that SFG only, so I have told you, like I've taught you another method how to solve it. So how you can solve it is, like if you want to find y of s upon E of s, right? So you take E of s as the output instead of the input. What you do is find y of s by R of s. Okay, this is already found out. Then you use output as E of s divided by, and input is R of s only. Okay, and if you take the ratio, you will get your answer. But this is homework for you. Okay, I won't solve everything because this lecture will go on forever. Okay, so let us do the other part. This one was the method 1. Okay, and what was this question? This one was 15 question, right? This one was the method 2. Okay, SFG equation. Okay, now let us do the 16 question, right? So this time what is the issue? This time again I will take the block diagram. Okay, now R is 0 and noise isn't there. Okay, so sorry, R is 0, like the input is 0 but noise is there, n is there. So n is basically representative of basically noise, right? So what do you have to find? We have to find when R of s equals to 0. So this one becomes 0, right? So this one isn't present right now. Okay, this one isn't present. Now what I will do is, either you can solve using block diagram reduction technique, or what you can do is solve using this SFG, right? So can I reduce this further? Am I saying this can I reduce this? So what I am saying is, no, I can't. I am not able to reduce this further, right? I am not able to reduce this further. So what I will do is, I will simply draw the SFG for this. Okay, simply draw the SFG for this. So what I can see here also 0, so I can do something from here. but as I am not seeing something in particular, so I will draw the SFG for this. So first I will name the nodes for this one, right? So let me name this as simply M, right? Simply M, N, O, P, and Q. Okay, so I named all the nodes. Okay, so this is 0, I know this is 0 already, I know. Okay, but still I'm taking the nodes just to not make any mistakes, right? It isn't harmful for you to take extra nodes. Okay, so what I will do is, this is, let me draw a straight line, right? Now this is M only, now this is N only, this is O, this is P, this is Q. Okay, this Q, and this is Y. Okay, so this is Y of S, this is P, this is Q, this is P, this is O, this is N, this is M, right? So like what is the connections? So between this M and O we have a gain of 2. So M and O we have a gain of 2. Now between the Q and O we have a gain of S by 2, right? Okay, let me keep this over top. Q and O we have gain of S by 2, but it is in negative sign. Okay, it is in negative sign, right? So we write minus S by 2. Okay, now between this Q and N we have a gain of minus 1 because this is negative, right? Okay, I should have written this in bit top, but that's fine. Q and N, right? Q and N we have a gain of minus 1. Okay. Okay, minus 1. So between M and N we have gain of 1, right? And gain of 2 here because this is plus. And between O and P we have a gain of 10 by S into S plus 1. So this gain, right, is 10 by S into S plus 1. Okay, and between P and Q we have a gain of 1 again. And the most important thing is, at the node P we have input as N, right? We have input as N of S. Okay, so from here we can find like also this point I missed, this is S plus 2, right? This is S plus 2 between N and, let me write this in this is S plus 2, right? So this is between N and O. Okay, so this is S plus 2, and now let us find how many number of forward paths are here. So what I can say is, this is one forward path, but is there any other forward path? This is also one, right? This is also one. Is there any other forward path? If I go from here, no, I have to come back, repeat it again. So number of forward paths is only one. So again I will solve this directly only. Over S upon sorry, not R of S, this has become a habit actually, N of S equals to one forward path, right? So what is the gain of the forward path? It is 1 times 1, so 1 only. Now what is the associated loop gain factor? So are there any isolated loops? So how many number of loops are there? So this, no, this isn't a loop. Okay, this isn't a loop, but like this, right, this is a loop and this also is a loop. But the problem is this PQ is common. Now for forward path I remove this, right? So the isolated loop is removed. Like there aren't any isolated loops. We have two loops and there aren't any isolated loops. They are all common between this node P and Q. I hope you're solving by yourself also. Now like I have already told you, but find the determinant. Okay, so this is only 1 minus 0. Now what will be the determinant? Always pause the video before when I try to solve. Okay, solve it by yourself, then you restart the video again. So this becomes, what is the gain of this one? So this becomes this is minus 1 only. Let me keep this in top. so that you won't get confused. So this is s plus 2. Okay, let me write here 1 minus s plus 2 into 10 by s plus 1 into minus 1. So minus 10 into s plus 2 10 into s plus 2 into s by s plus 1 into minus 1, right? Now minus this one is the another one, right? 10 into s by s plus 1 into minus s by 2. So this becomes minus 5 divided by s plus 1, right? Because the s gets cancelled, right? S gets cancelled. Okay, so now let us multiply with the denominator on both of this, right? Common s into s plus 1, let us multiply. So y of s upon n of s equals to simply s into s plus 1 we are multiplying. Okay, this is s square plus s, this is simply plus 10 into s plus 2, and this is plus 5s, right? Okay, so let me simplify this equation again. So what will be the like this is the delta, right? Delta should be common, right? For that single SFG. Okay, the delta is always same. Basically previously we see what delta we got, this delta, right? This delta will be same for here also. Okay, like if you calculate here, it's the same two loops only, right? Same two loops only, so delta should be same, right? So s into s plus 1, right? Now this is s square plus again 16s plus 20. So delta will be same because the SFC is same only, the loops are same only, but the difference is basically on the just the numerator part, right? Okay, the isolated loop and the forward pathway, those things are different. So this is the sorry, again I wrote r. This is just a habit, bad habit. This is n only. This is r of s equals to 0 when the input is 0, when you have noise present, right? So now what is the other question? This one was the 16th question. Okay, okay, this one was the 17th question, because this one was the 16th question. And this one is the 18th question, right? This one was the 18th question. So what was the 18th question? To write the whole transfer function, basically y of s for both when the both inputs are given, right? So this is a this is a LTI system. So LTI system follows the principle of superposition. So as this is a LTI system, it will the principle of superposition. It will follow the principle of superposition, right? So how will I write it? So basically I can write y of s as a function of simply the transfer function y of s upon r of s when the noise is 0 multiplied by r of s, right? So this will be my y of s when the as a function of r of s only, and I can write y of s upon n of s when r of s equals to 0 multiplied with n of s, right? So this will be a function of y of s for the input noise is 0, right? So you can expand this. Okay, we already found this one, and write this, so you will find your answer. Okay, so this was the first thing. Okay, so this was the solution to this question. So to this question we will learn multiple things, right? So input, it can be two, there can be two inputs, but we have to find it differently. We have to follow the principle of superposition. Okay. Also, for any type of system, CISO, CMO or MIMO, any type of system, right, the delta will be same. Delta will be same for any type of system. Delta will be same for any type of system if the SFG is same. Okay, if the SFG is same. Okay, so delta will be same for any type of system. So this was the solution for this question. So let us there is another question. So I will skip this question for now. First, what I will do is tell you the limitations of Mason's gain formula. Okay. After that, we will solve this question because this lecture will go on forever, or I will just give that question as a homework. Okay. So first, let's do this question. So what is the limitations of Mason's gain formula? So first, for that, let us understand what is a self loop. Self loop is that the point is starting from a node and it is coming back to the node only, okay, without any other path. Okay, so let me draw that. So first let us understand the concept of self loop, right? Let's say we have this path, right, and we have three nodes, okay, and this one, let's say, is let's say this one is y1, y2 and y3, and this node is coming back here only, coming back to this path only. And let's say like the gain of this is known as the self loop, right? This is known as the self loop, right? So what would let's say the gain of this is simply G, right? G22. Okay. The gain of this one is like a G22. So the gain of this one, right? Okay, this is moving. Gain of this one is G11. Okay, and gain of this one is G. Okay, let's say this is going from path 1 to 2. So I will name it like this, G12, and this is going from path 2 to 3. This is G23. Okay, so gain of this one is G23. So what I need to find y3 upon y1, right? Y3 upon y1. So how to find that? So before that, what I have to do is first find okay, let's just first find y3 upon y1. So what is y3 upon y1? Using the Mason's gain formula. So how many number of forward paths we have? We have only one forward path, because you might say, yeah, I will go like this, but I am repeating this node. Okay, but the definition of forward path was we shouldn't repeat any node. So we have only one forward path. So what is the gain of the forward path? It is simply G12 times G23. Okay, and what is the loop gain? So again, this is the only loop present in this forward path, and this loop is getting floated, right? So this is simply 1 minus 0. Okay, so we have only one loop, right? This G22 only, this is plus only. So the determinant will be 1 minus G22. So this is G12, G23, 1 minus G22. So this is the basically the forward path. Okay, this is the y3 upon y1. Now what I will write is, at the second equation, that is y2 upon y1. Again using the Mason's gain formula this time. Okay, using the Mason's gain formula, because there isn't any, the input is fixed, right? Input is y1 only. I can take output from anywhere, so that is not an issue. So y2 upon y1, what I can write here is simply we have only one forward path, that is G12, right? And how many number of loops are there? Again we have only one loop, and if I remove this, right, this loop becomes floating. So again G12 into 1 divided by 1 minus G22, right? So this is again my transformation. Okay, so if I solve this normally using the equation method, what do I get, right? So let me copy this. Okay, this one got also got copied. Solving this normally, this is from so what will this become? So simply this will become, right? So if I want to find like y3 in terms of y1, so what I will do, I will first write this equation. So what is y2 equals to? Y2 is equals to two variables, right? So we have to write the flow equation carefully this time. So y2 equals to this one, like y2 times g22 plus this flow equation, right? So y2 equals to y2 plus g22, okay, not plus, multiplied by g22 gain block plus y1 times g12, right? So now I can simply find y2 upon y1. So what will be y2 upon y1? y2 upon y1 equals to this g12 by one minus g22, g12 by 1 minus g22. Okay, so this is simply y2 upon y1. Okay, that's what we got up here also. Okay. Now let us find x2 upon x1. So what I will do is again write y3 in terms of y2 and replace y2 with y1, right? So what is y3 equals to? Y3 equals to g23 times y2. Okay, g23 times y2. So simply what it will be equals to, so what is y2 equals to? Y2 equals to this one, right? So I will replace y2 with this one in terms of y1. So y3 g23 times g12 into y1 divided by 1 minus g22. So y3 by y1 equals to g12 g23 divided by 1 minus g22. Okay, so this is the y3 upon y2, right? Y3 upon y1 basically. So again what I am saying is I solved it correctly here also. Okay, here the answer was correct also. But what is the problem? The problem is if the gain of the self loop, right? If the gain of the self loop is 1, then the system will be impractical. Okay, here, right? Here if the gain of the self loop is 1 and system will be impractical, hence Mason's theory formula won't work. Okay, anyways the normal equation also won't work. Okay, let me if the system will become impractical. System will become impractical. Why? Because as you can see, if I put g2 to 1 over here, the transfer function becomes infinity. Okay, so this which is not possible, because y3 upon y1 or y2 upon y1 tends to infinity, right? So if g22 equals to 1, what we have to do is we have to remove that self loop. Okay, then solve. So like again if I write it again with equation also, I will see invalid, right? What I will see is y2 equals to simply y1 plus G22 times y2, which is equals to y2 itself. What I see is y1 was 0, which is not possible, invalid equation. Y1 is not equals to 0, right? Look at this different actually. Yeah. Y1 is not equals to 0. So yeah, what we will do is, so in Mason's game formula, we will remove that self loop of unity gain. So let me write this in point wise. Okay. Not valid for a self-sustaining loop gain of unity gain. Okay. So what we have to do is remove the self loop, then calculate using Mason's game formula. Okay. So if nothing is said, right? If nothing is said, then you do this process. So this is just a procedure that I am saying. There may be different procedure. You may assume that gain as G22 and not equals to 1 and go ahead with that also, but this is just a simple procedure. So if I remove the this one, right? If I remove this one, then the answer will be simple only. So this one was actually another portion actually. So for what? Okay. So if I remove that self-sustaining loop, what will be the gain? It will be simply equals to y3 upon y1 equals to simply multiplication, right? We don't have any loops, g12 into g23. So this becomes very simple. Now let us solve an example question with this. So this is another example question. Okay, this is the 20th question. That one was the 19th question, right? So yeah, let me take one loop over here. This is a node and this is a node. Okay, and let's say I have a self loop here and a self loop here also. Self loop with -1 is not an issue actually. Self loop with only unity gain is an issue. Okay, so this is -3, this is -1. So just be careful. Only the unity gain causes us issues. The -1 won't cause us any issues, right? So this is 2. This is simply 4 and this is 3. Okay, so this is what the whole flow diagram is. Now what I will do is I will find the transfer function of r upon y, right? R upon y. Okay, find the gain of r upon y. What I can do, using simple write the equations also, using the Mason's gain formula also. So first let me write these equations. Okay, let me write the equation. Find y upon r. Right? So what do I write the equations as? So the equations, right? Method 1. So what do I write the equations as? So it is simply equals to, so here let me name the points. So let me name this as C1, this is C2, right? So C1 equals to minus of C1 plus 2 times R, right? So C1 equals to R only. Now C2 equals to minus of 3C2 plus 3C1. Now what is C1? This is 4C2. C1 equals to R, right? So this is 3R. So C2 equals to 3 by 4R. Now what is Y equals to? y equals to, okay, let me make it a bit better to be readable. Y equals to 4 times C2, so which is 3R only. So what is y by r equals to? Y by r equals to 3 only. So this is the gain. You can solve using Masons also. So if I solve using Masons, like SFG, right? If I solve using SFG, so how will I solve? So this is simply like one forward path we have. Do we have any forward path? No, we don't have any other forward path. So again simply multiply these, right? 2 times 3 times 4. So this is 2 times 3 times 4, and like we have 2 loops, but this is touching both of the loops, right? The forward path. So this will be 1 minus 0 only, and again the loop gains, right? So this is easy only. So this is minus 1 minus 3. Okay. So this is 4.8 only. Okay, sorry, I'm doing something wrong here. Okay, sorry, this is actually minus, wait a second, minus 1 minus 3 times 4, so this becomes 5, and like this becomes, okay, I forgot, okay, it's my mistake also. Like these two are non-touching, right? These two are non-touching, so there will be another form of loop, right? That's what happens. Okay, I'm a bit sleepy right now because I haven't slept recording at night. So yeah, we have to like add with the multiplication of the loop gains, because these two are non-touching, right? These two are non-touching. So this is minus 1 times minus 3, so this becomes 8 and this becomes 3. Okay, sorry for the mistake. Okay, so this will happen in examination also. You may go blindsided. Okay, so yeah, as you can see, Mason's gain formula is valid for this one, because the loop gain, right, the self loop gain is not unity, it is just negative one. Negative one works. Another limitation of Mason's gain formula is that Mason's gain formula, like I'll show you one example. So again we have this question, right? So this is a signal flow graph basically. This time the self-sustaining loop is in front of being in the middle. It is at the start, right? It is at the start. Okay. 2. Okay, we have another loop here also. 3 and 4. So this is let's say this is C1, this is C2, and this is Y, and this is R. So find Y by R. Okay, so what is the problem over here? The problem over here is, if I try to write this equation, right? If I try to write this equation, so I will write the flow equation. R equals to minus R. Again I see R equals to 0. Again this is a invalid equation. Okay, so what I have to do is remove this loop, right? Input loop, like Mason's gain formula is not valid for input loop anyways. Okay, so of any gain. So what is the issue? Mason's gain formula is not applicable for self sustaining loop of any gain at input, because the equations become invalid. Flow equations become invalid at the input, right? So what I will do, I will simply remove the self-sustaining loop. So what will that become? This is C, this is sorry, this is not C, this is Y, this is R. Okay, we have three nodes. This is C1, this is C2, this is 2, this is 3, and this is 4. And again we have one self-sustaining loop over here, and I find the gain like this one only. Okay, so I can simply use the Mason's gain formula again. We have only one loop this time, so solving this will be easier. So y upon r equals to, simply what is the forward path gain? 2 times 3 times 4 times 1 minus 0. What is this loop gain? We have only one loop, right? So minus 3 only. Okay, and this is 0 because this is touching this loop, right? So we don't have any isolated loops. So this becomes 2 times 3 times 4 divided by 4. So this becomes 6 only. This becomes 6 only. Okay, so yeah, we get our answer. You can solve this using equations also. I will give that homework to you. Okay, because we are running out of time. Okay, that is homework to you, how to solve using equations. So now we'll go back to our question, right? This question. So this question is a bit lengthy. This question is a bit lengthy. So this will take me a bit of time, but I will solve this using Mason's gain formula only. I will not solve this using the other one, because this is very lengthy. Writing equations will be difficult for me. Okay, so first what I will do is basically name the nodes, right? Name the nodes, and this is tricky also. Whenever you see this much of a big diagram, right? So you have to be very careful and check for the loops. How many loops and forward paths are there? It may so happen you may miss one forward path or loops. Okay, so just be careful with that. Okay, so again let me name this, name all the nodes, right? So what I will do is I will now name this as ABCD. Okay, this is A, this is B, this is C, this is D. Okay, and let's say this is E, this is F. So all the nodes are covered. Okay, all the nodes are covered. Okay, so now what I will do, I will write the forward paths. So stop the video right now, pause the video, and tell me how many forward paths are there. Okay, so what, from first glance what I can see is this one, yeah, is a forward path. This one is a forward path. I see two forward paths. Is there any other? So yeah, this one is also a forward path, right? And this one is also a forward path. So I see four forward paths. So are there any other forward paths? So like this is very difficult. Obviously, in first try also I didn't get it. Okay, so another forward path is like this one, right? This, okay, I missed. Okay, this one. This one is another forward path. Okay, so this is very difficult to get. Okay, first try also I didn't get. Don't worry. Okay, but obviously with practice, it may seem more easier to find the forward path, right? So this is another forward path, and this is another forward path, right? So how many number of forward paths we have? We have total 6 forward paths, right? 6, right? So let's now solve for that. Okay, solve for the forward paths. So this one you have to solve it slowly. Number of forward paths we have 6, right? So let me write each forward path. So let me write this one, the easier ones first. This one, right? So this is A, B, C, D. So R, A, B, C, D, Y, right? So what is this? Simply this is okay, this is G2 times G4 times G6. Okay, now okay, this is one forward path. So another forward path, okay, is this R F E D Y. Okay, R F E D Y. So what is the gain of this? Gain of this is G3 times G5 times G7. So G3 times G5 times G7, right? So now what is the third forward path? Third forward path. So the third forward path is basically this one, right, that we talked about. Okay, this one, right, this one. So it is A F C D. First we have R, A, F, C, D, and then we have Y. So we are going from here to here, right? So this is G3, G8, and G6. So if you can see this is G8, right? This is G8, okay. So if you can't see, sorry for that, okay. G3, G8, and G6. This is the fourth forward path, which is basically this R is going from here to here, right? So A, B, E, D. R, A, B, E, D. So this is basically G2, G1, G7. G2, G1, G7. Okay. G2, G1, G7. Okay, this is another forward path. So what is P5 equals to? Now this is the hidden forward path, right? So this is basically this one. Then we are going from here and here. Then what we are doing is, okay, sorry, I made a mistake. We are going from here, then we are going to here, then we are going this path, right? So this is A, F, C, P, E, D. So A, F, C, C, C. Too much of crackers at this amount of time. Also during the night they're firing too much of crackers. Okay, that just broke my sleep. Okay, I was feeling so much sleepy. C, D, then E, E and D, and then we have Y, right? Sorry for the noise actually. So what we have is simply R, A, F, R. We're going from R, F, then C, then B, like this, then E, then D, Y. So R, A, F, C, B, E, D, Y, right? So this is G3 times G3 times this upward one, which is G8, times this one, right, which is H2, times G1 times G7. So this is very difficult one, right? This is very difficult one. So we have let me check if everything. Okay, sorry for the noise again. Okay, sorry for the noise again. Like too many of crackers are flying right now. So yeah, one thing I have to notice here is, so this is what was I? G3 times G8 times H2. So G3, G8, H2. Let me write here only. G3, G8, H2. Okay. Then G1, G7. Sorry, G1 and G7, right? So this is G1 and G7. So like, let me rearrange this. Too much of noise, sorry. If this recording wouldn't have gone this long, so we wouldn't have heard all this. Okay, G1, G8, sorry, this is G7, G8, this is H2. So G1, G3, G7, G8, G1, G3, G7, G8, and H2. Okay, so now let me draw another last one, right? Last forward path. So what is this forward path? we're going from here, okay? A, B, then E, then F, then C, D. So A, B, E, F, C, D. A, B, E, F, then C, D. Obviously in examination, right, you don't need to write it. Sorry, just put your volume a bit lower, okay, for this sound. So obviously in examination you don't have to like write all this. Just for explaining it to you guys, I am writing all this, right? So what is the gain here? So G2 times G1 times minus H1, right? G2 G1 minus H1. G2 G1 minus H1. Now this is G8 G6. When will they stop, man? I also want to stop this recording actually, but sadly I can't. Just this is the last lecture. This is the last question. So this becomes G1 G2 G6 G8. At this night also they are like bursting like crackers. This is just this one is G1 G2 G6 G8 times minus, so minus H1, so this becomes minus H1. So what I will do is find the like the individual loop gains, right? How many loops are there? So finding loops also is difficult in this, okay? So this question is lengthy anyways. So how many, you solve it by yourself, how many number of loops are there, okay? So yeah, pause the video and solve it by yourself. So what I can see is I have one loop here, okay? Are there any other loops? Can I go from here to here? No, I can't. This is can I go from here? No, I can't go from here. Can I go from here to, okay, yeah. I can go like this, right? Sorry, really sorry for that sound. I can go like this, okay? This is another loop. So we have 3 loops, right? At this night they are bursting crackers. I don't understand why don't they like burst it during the evening. So 3 loops. Okay, we have 3 loops. So what is L1? L1 is basically this one, right? BCD. So it is equals to simply G4 H2. And what is L2? L2 is this one, right? FE. Minus H1, right? So this is L2. Now what is L3? L3 is a bit difficult. So it is, we're going from here to here and then here, right? So if I start from B itself, right? So B to E to F to C and then B. So B, E, F, C and then B again. So what is this? This is H2 G1 minus H1. So H2 G1 minus H1 and this is G8. So minus of G1 G8 H1 H2, okay? So this is the third loop, okay? So let us find, are there any non-touching loops? So yes, these and these, right, are non-touching, but this loop is touching both of them, but these 2 loops, right, these 2 loops are non-touching. So this is the lengthiest question, but this will help you revise the full SFG, right? So this is L1 L2. So L1 L2 is simply minus, we have first G4 G5 H1 H2, right? So this is the loop gain basically. Now what is the, are there any 3? No, there are only 3 loops, right? So there can't be any 3 non-touching loops because the other one is touching both of them. So what is the determinant? It is simply G4 H2. Now this is minus G5 H1 plus minus G4 G5 H1 H2. Okay, this is delta. Okay. So what will this become? So this becomes simply G4 G5 H1 H2. Okay, so this is the delta. Now what is the isolated loop gain? So if I remove, like I have to find for 6 paths, which will be very difficult, but you may observe one thing, that whichever loop I go to, right, whichever loop I go to, I have to cross this path also. So this B, C are always common, but the main thing is, like when I am crossing through this path, then this path is not present. Okay, so I will just check where BC is not present and where FA is not present. So these two things are the most important things, right? Okay, so I will check either BC or FE are not present. These are the loop points, right? These are the loop points. Okay, so in the P1, right, we have BC present but FE is not present. So L2 is not present. So for that will be easier for us to calculate. Okay, or you can draw from diagram also. Okay, isolated. Okay, so delta 1 will be, so we have only 3 loops. One loop is touching everything, right? So it can't be possible. The other two, the above, like top and bottom one, are just the non-touching ones. So it will be 1 minus simply this one, right? 1 minus simply so we don't have FE, so this will be G5 into minus H1. Okay, so let me like do it a bit slower, because you may not understand. This is minus G5 into H1. So this is minus G5 into H1. We don't have any other loops, right? Because the other one is common node. Okay, that is touching. So we have G5 H1. Okay, 1 plus G5 H1. Now what is delta 2 basically? What is delta 2? So delta 2, right? If I see the second path, we have FE in common, but BC is not common. So again, for delta 2, what I will do? This is for path 1. For path 2, this will be simply L2 dash, right? L2 dash is the other top path is not common. So this is G4 times H2. So G4 times H2. Okay, now what is delta 2? It is 1 minus G4 times H2. Okay. Now for the third path, what is common? So for the third path is F is there, but BE is not there, right? BE is not there. Okay, so what I can do is, okay, this is C, sorry, this is C. C is also there. F is also there, C is also there, right? F and C both are there. So for the third path, it will be simply 0. Okay, it will be simply 0. And for other path also it will be 0, because B is there, E is also here. So E is also here and B is also here. So both of this loop are cancelled. And for this path also, F is there, B, E, everything is there. Okay. For other paths, the isolated loop gains are 0. So let me write this like this: delta 3 equals to delta 4 equals to delta 5 equals to delta 6 equals to 1 minus 0, which is 1 only. Okay. So what will be y by r? So y by r will be simply P1 by delta 1. Okay, you just put this in the equation, you get the answer. I am not putting this in the equation right now. Okay, now delta 3, all of these are 1 only, and denominator we have single delta, right? Single delta. So I have calculated the delta here and put this here. So let me put this, copy and paste this over here only. Okay, why is this not pasting actually? Okay, this is pasting. And what is the P1 and delta 1? I hope you can solve, right? I hope you can solve all these things. So let me write it anyways. But solving this is your duty, right? This video is already gone very long. Okay. So I will not write this actually. I hope you are understanding. You will not write this because all of this is very this will again take time. So yeah, this is the end of this lecture. So mainly the questions that I solved, you just see the procedure and repeat those procedure again and see like what I am skipping, what I am not skipping. Okay, it is important like which questions to solve slowly and which questions to solve in a lengthy manner. But the main important point was the limitations, right? Now limitations, the equations aren't valid anyways. So the Mason's formula also won't work. Okay. So what is happening if self loop with unity gain is there anywhere, it will be not valid. The equation won't be valid. Okay. Now if we have a self loop of any gain at the input, then also the equation won't be valid. Why? Because the equation will be invalid. The input will become 0, which is not possible. Okay. That's why I will just remove all these sounds. Okay, that's why we don't use the that's why what I was speaking like that's why we don't use we remove those loops, then we solve the equation, then solve the SFG signal flow graph. Okay, so yeah, this was basically the it for this lecture, because this lecture is already gone now, so I won't revise it. That was the revision. Basically just try to solve the questions in the method that is most suitable for you. You can use either combination of that equation and block diagram reduction technique or the SFG. You can either use block diagram reduction technique and SFG also. Combination you can use, but you can't go from SFG to block diagram reduction technique. Okay, it is difficult. Okay, so that is it for this lecture. And in the next lecture, we'll start a new chapter, that is the state space equations. So that will be very interesting chapter. Okay, so yeah, thank you for watching.